Find the second derivative of each of the following functions. Okay, well, the first two of these are just power rule, and so they're going to go kind of quick. C will be a minor hassle because it has quotient rule in it, although the numerator and denominator are not all that complex. And this involves chain rule because we have a polynomial with a power on it. That'll stretch this one a little bit. But A and B should go down pretty quick. F df dx, I'll go back to my favorite format, should be 9x squared minus 18x plus 16. The derivative of 5 is 0, so that disappears. And d squared f or dx squared. The second derivative is 18x minus 18. The derivative of 16 drops out too. So typically with a polynomial, every time you do a derivative, the degree drops by 1. We had a cubic, which turned into a quadratic. That turned into a linear function. One more step and we just have the number 18, and every derivative after that would just be 0. In B, that actually happens. If we do df dx here, the first derivative of this is 10. It's a straight line with a slope of 10, so its first derivative says the slope is 10 always. And the second derivative is like saying, how much does 10 change? And the answer is, it does not. Its rate of change is 0. C is a quotient, as mentioned, so the derivative for a quotient is bottom d top minus top d bottom over bottom squared. Let's see what that looks like. Bottom d top is 4 minus top. The derivative of the bottom is just 1 all over the bottom squared. That cleans up to 4x minus 28 minus 4x all over x minus 7 all squared, which is minus 28 over x minus 7 squared. The second derivative, there's two ways you can handle this. You could do quotient rule again, and you do bottom times derivative of the top minus top times derivative of the bottom over bottom squared. Or, if you want to avoid doing quotient rule, this could be written as minus 28 x minus 7 to the minus 2. Right? Minus saying we're dividing by this rather than multiplying by it. Either way, you should get the same derivative doing those. I'll go back to quotient rule just to prove that it doesn't scare me too much. But changing it into a product is effective, and it's a good idea sometimes. If we do this, we have bottom times the derivative of the top, which is 0, minus the top, times derivative of the bottom. First, this is a power, so its derivative is 2x minus 7 to the first power, times the derivative of the inside, which is, well, 1. If you'd forgotten that, you would have gotten away with it. And bottom squared is x minus 7 to the fourth. So this whole thing vanishes because it's multiplied by 0. And for our second term, let's see, we have minus negative 28, which is plus 28, times 2 is 56 x minus 7 all over x minus 7 to the fourth. Of course, we can divide the top and bottom by x minus 7, and that lands us at 56 over x minus 7 cubed. And that looks like a good place to stop. For D, chain rule happens with our first derivative, so we get dy dx equals 3x squared minus 5 squared times the derivative of the inside, which is 6x. If we clean that up, which you normally want to do, 3 times 6x is 18x times 3x squared minus 5 all squared. So there's our first derivative. Now we need a second derivative, and the second derivative, unfortunately, is a product because of how the first one looks. We've got 18x here times this other piece. So remember your product rule. First d second plus second d first. First part is 18x. The derivative of the second, now we get chain rule. 2 times 3x squared minus 5 to the first power times the derivative of the inside, which is 6x. So that's first. All this is d second plus, now we get second d first. The derivative of the first is simply the number 18. If we clean all that up, let's see, what can we clean up here? We could factor an 18 out of both terms. We could factor a 3x squared minus 5 out of both terms. I'm trying to factor aggressively because I'm hurting for space here. If we take out an 18 and a 3x squared minus 5, this first term has lost its 18, it's lost its 3x squared minus 5. What's left is x times 2 times 6x, which is 12x squared. This term has lost the 18 and a 3x squared minus 5, but it still has another 3x squared minus 5. And so if we finish cleaning this up, we get 18, 3x squared minus 5, and what's left here is 15x squared minus 5. You could factor a 5 out of that, and I don't have room to do it, but if you do, I would recommend it. Your next line would be 90 times 3x squared minus 5, and then because these have had a 5 factored out of them, you'd be left with 3x squared minus 1.